video, we will be learning about precedence and associativity of arithmetic operators. As in the previous video, we have learned about various arithmetic operators. Also, the link will be placed in the description and an I button at the top right corner of this video. Now let's understand how exactly precedence and associativity works. So as we know, in arithmetic operators there are two types. One is binary and another one is unary operators. The associativity and precedence is highly used for binary operators and not for unary, and I'll explain the reasons as we go along. First, let's understand the precedence for the binary operators. So binary operators, as you know, these are generally our addition, subtraction, multiplication, division and modulus. So here the bracket has the wildcard. It has the highest precedence. So what does the precedence means is generally the rank or priority. So it's just an example. If there's an expression x into y plus z, how do you perform it? First you multiply x into y and you get an answer, and with that answer you going to sum it up with z, right? So here you have prioritized doing multiplication first, right? So you say that the precedence of multiplication operator is higher than the precedence of the addition operator. So there are few rules for this. First thing is the bracket has the highest precedence. What I mean is, if for the very same expression, if there is a bracket for y plus z, then you need to perform this operation first, and then you need to multiply the value of this operation into x. So this bracket has the highest precedence. So generally the precedence comes into the picture when there aren't any brackets in an expression. Like, let's take an example. If there is an expression x into y plus z minus m. So as if we have a bracket, then we are obviously sure that first you need to perform the operations that are present in the bracket. So when you don't have a bracket, then you need to understand the precedence rules and why associativity is used. So generally the rules of precedence are the highest precedence is given to the brackets, then after that the precedence level for multiplication, division and modulus, which means remainder. The precedence of all these operators are same, and also after that then comes your addition and subtraction. The precedence of addition and subtraction is the same. So if you want to understand what exactly precedence rules are, generally in the mathematics, when you perform calculations, you have this rule, right? BODMAS, where first you need to perform the operations related to the brackets, and then of, then division, then comes your multiplication, then addition, and then comes your subtraction. So similarly for arithmetic operators, these are the precedence. First you need to perform. But here in the mathematics we have clear rules that first it's division and then it's multiplication. But here the precedence is same for multiplication, division and modulus. And also it's same for addition and subtraction. So in order to clear the ambiguity between the operations, if they are of same precedence, then the associativity comes. So what is an associativity in general is, it tells out the direction of operations. I mean, associativity is generally, it gives out the direction. So for arithmetic operators, the direction for associativity is left to right. So what does it mean is, if you come across any expression, something like x into y divided by z. So let's consider the upper example. In this example, we know that the precedence of multiplication is higher than addition and subtraction. So obviously we are going to first perform x into y. So similarly, if there is an expression where there are multiple operators and the precedence is same, so how do you perform this expression? So then comes the associativity, where the rule states left to right, which means when there are operators of same precedence, you should check them from left. So whichever operator comes in the first from left, you need to perform that. As here multiplication and division are of same precedence and multiplication comes first when you see from the right. So first you execute x into y and then you take that value and then you divide it by z. So that's how the calculation is done. So now let's consider an example. 90 plus 20 by 2 minus 10 into 3. So let's see how we calculate this type of expression. So as we can see, the highest operator precedence is for division and multiplication. And when we have a same precedence operators, we check for associativity. So as the division comes first from the left, we perform 20 by 2 first. So we get 10. And as we go to the right, we perform 10 into 3. So we get 30. Let's write down the remaining operators and operands that are left. And now we have plus and minus, two operators, and the precedence of addition and subtraction are same. So we will again use the rule of associativity, and as the rule says, we need to go from left to right. First we perform 90 plus 10 and it gives 100, and then we perform subtraction of 30, then we get an answer of 70. So that's it. So these are the general precedence and associativity rules for binary operators. But there is a slight problem for unary operators, that is, writing unary operators in a single expression are kind of prohibited. I mean, it is written in the documentation that if you write an expression with multiple unary operators such as multiple pre-increment and post-increment or decrement in a single expression, it might lead to undefined behavior and you might get any kind of output. Now the kind of output depends on the compiler. So logically there isn't any proper explanation because it is syntactically correct, because you can write like this, right? You can write x equals to 0, initialize x equals to 0, and then y equals to plus plus x plus 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 x plus 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 x. So how do you generally see it? Because we did speak, when you write plus plus x, it means that the value gets modified at that instant and x takes that value. So here you can see plus plus x, then we can consider it as 1, and then plus plus x, now the value of x is already changed to 1, and you again pre-increment it, then the value of x is modified to 2, and then plus plus x, again the value is modified to 3. But sorry, here we don't write this expression, these operators are at once. So the thing is that the precedence of unary operators is higher than the binary operators. So first, the values of the unary operators gets modified. First this goes to be 1, then it goes to be 2, then it goes to be 3. And addition is from binary operators. Then comes your additions. So now the summation goes to be 3, 4, 5, 6, right? But there are compilers which gives the value 7, and there might be some compilers which might give the value to be 99 and many other values. So what does the documentation of C and C++ says that if you write expressions consisting of multiple unary operators dealing with the same variable, then you might get an output of undefined behavior. But whereas if x is 0 and y is 0, you can very well write an expression z equals to plus plus x plus y plus plus. As there are two different variables, the behavior can be listed properly, because x is going to be modified at that instance, so it goes to be 1, and then y plus plus. So at this very instance, the value of y will be 0. So the value will be z equals to 1. Of course, the value of y is changed, but the reflection of getting changed won't be captured at that very instant. But if you print out the value of y at this moment after this execution, then the value of y would be 1. But as you can see, this is perfectly fine here, because you are using two different variables. Using different variables in one single expression with the unary operations is fine. You can get a defined behavior, but using unary operators in a single expressions with same variable, you might get undefined behavior. And the important aspect of this is, no matter you understand the precedence and associativity of binary and unary, it's very important to always use brackets when you write down any expression in programming languages, because in future you might be working in a project and you might be having various statements in your loops and calculations, and there might be other programmers who's going to recheck or work on your project at these instances. In order to make sure that others understand your code very well, it's important how readable you make your code to them. So if you use brackets, then it's clearly seen which calculations are going to be performed first. So no matter how good logical person you are, it's safer to use brackets and gives more readability for any other people who are referring to your programming style. So that's it for today's video. We will be discussing more on conditional branching and loops in the upcoming video.